Hello students, and welcome back to inverses one more time. This time we're going to look at f of x equals x squared minus 2. Oh, they've got something funny in here, haven't they? X is less than or equal to 0. And we're going to find the inverse function, f inverse of x, like we have before. Wonder why they have that x is less than or equal to 0. Let's play around with the graph here just to help us think a minute. Let's see, remember when we did parent graph, x squared? We had our vertex here. Well, this says we're going to move down 2, so we'll actually have our vertex here, won't we? And a parabola is U-shaped, isn't it? That really is on minus 2, pretend. So why do they want me only to use half of it? They want me to use the half where x's are negative or 0. So this is what they're wanting me to use right here. And pretend that this other was never even there. Do you remember that both the function and its inverse had to be functions? That meant that f of x had to be 1-to-1 or pass the horizontal line test. It passes the horizontal line test so long as we don't have this side there. It would not pass it if we had that side there. So that is why they have limited our domain for us. So if they hadn't told us, we wouldn't know what to use, which half of the parabola or which part of the parabola. So let's get us a blank screen here and work this one. F of x equals x squared minus 2. And we don't even have to figure out our domain here because they've given it to us. So the domain is x is negative or equal to 0. The range, let's see. If I'm plugging in numbers for x and squaring them, I'm getting a positive number minus 2 most of the time, right? If I plug in 0, I get negative 2. So y could equal negative 2, so I'll put the equals. Then I get a number a little larger than 0 and subtract 2. A little larger than that and subtract 2. So I'm going above negative 2 because I have negative 2 and then I add something to it, add something to it, add something to it here. So y is greater than or equal to negative 2 for my range. Plug in a y for my f of x. Have the inverse now by switching x's and y's. We also switch domain and range. So my new range for f inverse is y is less than or equal to 0 and x is greater than or equal to negative 2. So that's f inverse. And now we'll solve for y like we do. So first of all, we want to get the y squared by itself by subtracting 2 from both sides. So on one side, did we check our arithmetic? Guess what? Minus 2 and minus 2 doesn't give me 0, so I was thinking backwards. Now remember, that's what you have to do. Check your arithmetic rather than assume it works. So now, if I add 2, this will go out. And now, on one side, I have a y squared. On the other side, I have an x plus 2. All right, so next, if something squared equals a number, then what I'm squaring equals plus or minus the square root of my number. Now you say, but Miss Heaton, you usually say constant. I do. And if I'm solving for y, x is a constant, sort of, in relation to y because I'm solving for y. So I treat it like a constant for a few minutes. So let's think about this. Now our square root function, parent function, looks like that. And then if I took the opposite, ooh, I wouldn't have a function, would I? What went wrong? Oh my, let's think about this a minute. Let's look back up at our domain and range. See if we can get a clue there. X has to be greater than or equal to -2. Well, that's obvious right here because this has to be positive or 0. Well, let's look here at our range. Y is less than or equal to 0. I think we found it, y'all. If y is negative, we would have to pick this sign and not this one. So we really have y equals the opposite of the square root of x plus 2. So now F inverse equals the opposite of the square root of x plus 2. I don't have to write anybody a note to tell them to use numbers greater than or equal to -2 because they're going to do that naturally when they see a problem if they choose the numbers they're not supposed to choose. So why did I need to keep up with the domain and the range here? Because it determined whether to use the plus or the minus of my square root function. So that was kind of sneaky. I told you that eventually we would hit a problem where it would bite us if we didn't keep up with the domain and range. And we wouldn't have known what to do if we hadn't been keeping up here. So this was the one, or one of the ones I was talking about. All right, let's look at a new problem. We're going to find the inverse for the function f of x equals x minus 2 cubed. Boy, we're going to keep up with that domain and range, aren't we? So, first of all, let's put in a y and talk about the domain and the range. The domain is going to be all reals because I don't have a denominator to become 0. I'm not going to use an even radical anywhere in the problem. And the same thing for the range. It doesn't matter what I put over here. If I have to use a cube root, I can take the cube root of all numbers. So we're really dealing with all reals for the range and domain of f. All right, let's get the inverse now by switching x's and y's. And that's rather trivial to switch the domain and range because it stays the same. But we want to keep up with it in case we reach another problem where we'd be in trouble if we didn't keep up with it. Now we'll solve for y so that we can use inverse notation in a few minutes. So let's see, I need to take the cube root. So the cube root of x equals y minus 2. Let's add 2 to both sides to get just a y. So on one side we have y, check our arithmetic, equals. On the other side we have cube root of x plus 2. And now we'll use our inverse notation. F inverse of x equals the cube root of x plus 2. And we don't need to write anybody a note because they can use all real numbers. That one was quick and easy, wasn't it? So let's look at another problem. See if it's quick and easy or one of those we have to think on. We're going to find the inverse for f of x equals the square root of x plus 1. Okay, and put it in function form like we've been doing. Okay, so first of all, I'll say y equals the square root of x plus 1. And let's think about this. The domain, well, I can't let a negative number get under the radical, so x has to be positive or 0 because that's what's under the radical. Now, what all does y take on? This is a positive number and this is a positive number, or this is 0 and this is positive 1. Well, if we use 0 for x, we'll get 1 for y, so we know y could equal 1. Now, the rest of the y is greater than 1 or less than 1. Well, this refers to the positive square root of x. Always when we see the radical by itself with nothing in front, it's talking about the positive square root of x. Any even root works that way. All right, so we have some number that's positive added to 1. That means it's getting greater than 1. So my range would be y is greater than or equal to 1. That's my F. Switch my x's and my y's to get the inverse. And then solve for y. All right, getting y by itself, I'll subtract 1 from both sides. And I have square root of y on one side, double check my arithmetic. And I have x minus 1 on the other side. So now I'm going to square both sides, not just each term on the right side, but the whole side. So I have y equals x minus 1 quantity squared. And when I got the inverse, my domain of my inverse switched, or domain of the function f, switched to become the range of f inverse, so y is greater than or equal to 0 for f inverse, and x is greater than or equal to 1 for the domain of f inverse. Now, if you walked in and saw this problem on the board, you would think it was a parabola unless somebody told you you can only use certain x's so that you only have half a parabola and it passes the horizontal line test. So part of the answer is writing this in right here so that people know we're not graphing a whole parabola but just a piece of a parabola. So changing to inverse notation now, f inverse equals x minus 1 quantity squared, given that we have to pick x's greater than or equal to 1. Okay, I've got one more thing I want us to look at with inverses. We're not going to find any more. We're going to go back to an inverse that we found a few minutes ago. Notice this is an inverse, and this is the original function, and I'm going to graph them for us here. So let's pull up our grapher. And if you will notice here, I have y equals x minus 2 to the third in there. Isn't that the one we had? Well, the one I brought up last anyway was x minus 2 to the third power, and we had found the inverse to be x, the cube root of x plus 2. All right, let's think a minute. The cube root of x plus 2. I type that in as x to the 1/3 because remember, if we have a cube root, we can write it as x to the 1/3 rather than the cube root. So here is my function, here is my inverse, and here is y equals x, and you may wonder about that. And here's the graph right here. But it doesn't go very far. It doesn't look like I have a normal screen. So I want to show you how to adjust your screen anytime it's not the regular screen. Go to Zoom and you'll see Z Standard. That's selection 6. And notice it graph with the standard screen. The only problem is I can't tell the inverse from the function. Let's do something about that. Let's go back to our y equals. toggle over to the left side of y. Now remember, that's our function. And I'm going to go enter. And notice it changes to bold. That's what I want. So I'll go down here and I'm going to leave it like it is. Let's see what I might do to this one. See what my choices are. I don't want another bold. And I don't want any triangles. I don't want that. I think I might like a dotted line. Let's graph it this way then and see what happens. There's my original function. There's my inverse. And there is my y equals x, which didn't get very dotted. Now, you know something? This tick mark here is wider than this tick mark here. So to change that, I'm going to go back to zoom and do zoom square, because what I'm trying to illustrate looks a little better with zoom square, or a squared graph, so that all my little crossings will be squares instead of rectangles if I drew in the whole grid. Now, think about this. Think about folding the graph down this line right here. Wouldn't this fall on this, and this would fall on this, and this would fall on this? That's a quick way to check and see if your main function has the inverse that you found, because if it does, it will fold over on each other when you put y equals x in the middle. So that's something kind of interesting to know. So that concludes our inverses now. We have found out how to tell if we have inverses by the definition. And that was, if both f and g are functions, then f of g of x and g of f of x both had to be x. We have found how to compute an inverse when we had to restrict the domain or the range any to get it to come out right. And we've also looked at what the graph of inverse functions might look like. So that concludes inverse functions.